welcome back. We're doing the walkthrough on 6.5, rhombuses and squares. So again, we're going to be using our notes, and we're going to this time be looking at the properties of the rhombus and of the square. So as to review, the rhombus has 4 congruent sides and the diagonals are perpendicular. They hit at a 90-degree angle. The square has both right angles on the sides and the sides are congruent. So the square is the properties of both the rectangle and of the rhombus at the same time. Looking through our new theorems, we find that the rhombus has a theorem. This is the rhombus of the diagonals of a rhombus theorem, which states that if we have a rhombus, then the diagonals are going to bisect opposite angles. So you end up with something that looks a little bit like that picture right there. All of that could come into play along with our properties of parallelograms, because rhombi, and squares are all parallelograms. So taking a quick look here, it tells us that this quadrilateral DKLM is a rhombus, so all the rules of rhombus and parallelogram are going to apply. It tells us the measure of KD, which is one of our sides, and it wants us to find the measure of KL, which is another one of our sides. So looking at your definition and properties of a rhombus, that one should be fairly simple because sides are congruent in a rhombus. That's the same sort of thought process you're going to go throughout the rest of this. You have measurements of angles, so be very careful looking at which angle it is that you're talking about. Thank you very much. This says measure of angle KAL. So just to recap on how you measure your angles, you're going to start at K, go toward A, then turn around and go toward L. So that means we're talking about this angle right in here. So using your definitions will help you find the measure of that angle. Let's look at the next page. You've got a 2-column proof. This is all about looking at your given and trying to figure out what you need to say in order to show that the thing is a rectangle. Let's look at our properties of rectangles really quick. Looks like the only big property to distinguish a rectangle from any other parallelogram is that diagonals are congruent and we have right angles on the corners. The thing is that this information doesn't tell me anything about angles, it just tells me about pieces of the diagonals, which means I definitely want to get some sort of statement saying that the diagonals are congruent. So in order to get to this prove line, I need to first state that my diagonals, RT and US, are going to be congruent to each other. Notice I'm setting you up at the start of a flowchart proof. So if I can state this, then by property of rectangle, I can say that that figure is going to be a rectangle. Now I've got to figure out what information I need in order to say that these are congruent, and I will give you one hint to help get you started, and that is by definition of congruence, I can say that their measures are equal. Using this information along with this that was given to me, that we have a bunch of sides being congruent, I can use some algebra in order to do some substitution somewhere and make this happen. So I'll leave you here with that thought process to find how you're going to bridge from this statement up here. I use my definition of congruence to go from all of these things are congruent to each other to their measures are all equal, to stating that the measurements of the diagonals are equal, that then by definition of congruence allows me to say that they're congruent, which then puts me right in the neighborhood of my property, which then allows me to state that the figure is a rectangle. Okay, so this is your part right in here. This is the hard part for you. I've given you the bridge. Please be sure that on the left-hand side, you write all of your statements, of which the things inside the boxes and circles that I wrote will be statements. And then on the right-hand side, that you write your reasons. That is all of the stuff outside of the shapes that you wrote and drew in are the reasons. Please make sure that you always start with the very first thing that you were given, which is the given, obviously, and so all the stuff that you were given becomes the first line of your 2-column proof. I've run out of space there, I'm sorry. And so you'll write all of this all over again. Please write it more neatly than I am, because I am just not writing neatly today. You're welcome to take a marker or highlighter and make this line a little bolder for yourself, so that way it's easy to tell that I am done with that particular statement and I'm moving on to statement number 2. Okay? You'll continue along that path until you get to the very bottom of the proof, in which your last statement will be this prove line, but its reason will be how you got there from the previous statement. Doing some more coordinate geometry, make sure you graph each set of vertices. Again, I encourage you to pick up some of the graph paper that I have in Classroom for you. If you do not have your own, you're welcome to cut it out and put it in here, or just attach and write down what number you're working on. They want you to decide whether the parallelogram that you've been given is a rhombus, a rectangle, or a square. Please make sure that you list out all the ones that apply. Remember that a square is both a rectangle and a rhombus. And please explain. So you need to be able to state something about things hitting at 90 degrees, things being the same size or congruent, maybe diagonals hitting at 90 degrees or diagonals being congruent, along with any of the other properties that you can find under the parallelograms that might be of use. Please make sure that in your explanation that you are using slope formula, that you are using distance formula, and if you think it's necessary, I don't know, maybe a bit of midpoint formula as well. So please make sure you have some really good, strong justifications on those. Otherwise, be ready to have a not enough work to support written on your paper, and then you'll have to go through and make that happen. Okay. So that was 6.5. I'm going to go ahead and cut here to make this a short upload, and we'll be back in a moment with 6.6.